great privilege to introduce a friend of mine. Now, this is fun because Luke actually lives here in Nashville, Tennessee, in the U.S. with me. Matter of fact, he lives right up the street from me. He's broadcasting from about a half-mile away. Luke and I regularly get together. Matter of fact, we were together last night for a birthday party for a friend of ours. I even get to babysit his kids sometimes, which just shows you what a reckless father he is. But anyhow, Luke is one of the co-founders of FoxyCart.com, great e-commerce solution. If you've heard me ever do any of my Voices of the Elephant podcasts, you've heard me mention them because I love what they do and just believe in what they do. But Luke's going to talk to us about his experience at FoxyCart and how he got to where he is now with being one of the thought leaders in the REST space. So Luke, having said all of that and built you up, I'm going to go ahead and turn it over to you. Let me swap your media slides. Are you with us?
I am. Thanks so much,
Okay.
Cal.
You're in charge now.
Oh, thank you. It's really an honor to be here kind of in the inaugural European Nomad PHP. I'm going to do my best to kind of tab back and forth a little bit between the meeting and also the IRC channel. So if you guys do have questions, I'm totally able to answer those during the presentation. I do like interactions, so these kind of virtual things are a little interesting. But what we're going to do today, we're just talk a little bit about our company. We're going to talk about REST and how those met the needs that our company had. And we're talking about a little bit, show some screenshots of our API sandbox and explain kind of some points of Hypermedia APIs. So myself, my name is Luke Stokes. This is how you can contact me. I'm pretty active on Twitter. That's kind of my preferred social network. So I'd love to hear from you guys on Twitter. I'm just at Luke Stokes. You can also email me directly or check out my personal blog. And I am the founder and CTO of FoxyCart, which is an e-commerce shopping cart platform that we started, my buddy and I, Brett Florio, started back and really started tinkering with it in 2005, 2006, and we incorporated in 2007. We now serve thousands of merchants all over the world and have a lot of fun with it. We've got a small team, small international team, all virtual. And our goal is really to be a platform as a service, not just a software as a service. People are building their businesses on top of our technology. So you've got things like Foxy Shop and Foxy Press, which are WordPress plugins, and Foxy Pow, it's a Drupal plugin, and there's a whole bunch more coming as well. So we have to be built to integrate. We're kind of when one size fits all or doesn't work, that's kind of where we come in. We just do the cart and checkout. We're not a CMS, and so because of that, it's really important that we are built to integrate. So we have to be able to expose our data. Pretty much everything that happens within the FoxyCart admin. For example, if someone's going to build an e-commerce solution to a hosted content management system, they need to be able to do everything they can do in the FoxyCart admin within their interface. And that's where the API became a really important thing. So when we started the company, we started with just a plain old XML API. We had a lot of confusing API actions, and there was not a whole lot of consistency. You know, you get your store includes get and subscription modify and different things like that. And it just over time, as it grew and we added more features to it, it just got more and more confusing. And we'd have to constantly keep checking the documentation over and over again to remember. Yeah, and I built the thing, and I'd have to go and remember. Wait, what was that? What was the order of that? And how did that go? And the request response model was confusing, and there was a lot of tight coupling between the client and the server, and that's not ideal. So when we think back to here's a very, very brief history of APIs in the internet. It started as middleware, really expensive stuff. Went from there to remote procedure calls. From there to simple object access protocol, which is basically an envelope and a message, and it tells you how to process that. On from there to the web services description language, and a lot of different things from there, the whole web services stack. And really what these have in common is tight coupling. If the server changes, it's probably going to break the client. And if the client changes in certain ways, it might even break its interactions with the server. And one example I love to use when I talk about REST is when you go to a website and you type in, ESPN.org or whatever, and they change their content completely. Your browser doesn't go, oh, I got a message I don't know how to deal with. You need to upgrade your browser. It just doesn't happen because the browser understands HTML content and understands how to work with those different media types. And it's like, hey, I can process this new content I got. And it just moves along pretty happy. And that's been around for quite some time since Roy Fielding did his dissertation. And it's only recently, I think, that people are getting really serious about taking that idea that's worked so well for the internet and bringing it to APIs. And one thing that's interesting, I was actually thinking about this morning, as I look at this list, it's kind of moving from a kind of one use only, really expensive and centralized solution you have in middleware to like a reusable tool set that is distributed and open when you think about REST and the way you can build REST tools that can work with multiple APIs potentially. So some really exciting stuff. So when we started thinking about rebuilding our API to expose our data and make it more available to our clients and our users, we thought, wow, hey, there's a lot of crud in our particular situation. Not all APIs are going to be this way, but because we're exposing our admin, there's a lot of manipulation of data, so a lot of crud. And so all those confusing methods kind of go away. And with REST, which is representational state transfer, we can actually represent this data and be able to work with it directly with HTTP methods, which is really great. And from the Wikipedia, I'll just go ahead and read this real quick. It says, representational state transfer is a style of software architecture for distributed systems such as the World Wide Web. REST has emerged as the predominant web service design model. The term representational state transfer was introduced and defined in 2000 by Roy Fielding in his doctoral dissertation. Fielding is one of the principal authors of the Hypertext Transfer Protocol, HTTP, specification versions 1.0 and 1.1. Conforming to the REST constraints is generally referred to as being RESTful. And we're going to talk more about what the REST constraints are. But if you're interested in this stuff and you really want to build your own Hypermedia APIs, I'd encourage you to actually read Roy Fielding's dissertation. I think it's chapters 5 and 6 that talk about REST and kind of where this all came from. And one thing I want to clarify too, REST isn't just HTTP alone. Actually, just last week, Joel's there in the chat room. He was there with me. We were at the restfest.org, great REST API conference, very small. Everyone gets to talk. And there was people even talking about you could use sockets. You could use a lot of different things as a transport layer. It doesn't have to just be HTTP, but that's beyond the scope of this presentation, so we won't get into that too much. Another nice benefit that we found by thinking about REST compared to our existing XML API is that we've got some standard response codes. We actually, instead of building our custom error messages, we can actually deal with HTTP message code, which is really, really fun. And so this tells us, the 100 series is informational, 200 series success, 300 series redirection, 400 series is the client screwed up, 500 is the server messed up. And I'd encourage you to hit that link later and check out the different status codes on Wikipedia. They're good to know as a web developer, web professional. These are things you definitely should know. And there's also I think there's like a lolcats version of it too, which is pretty awesome if you Google for that. So we decided, okay, we're going to do REST. This is going to be awesome. And this was probably about 1.5 years, 2 years ago when I really started out on this journey. And I was like, okay, show me one. That's what I want to see. I want to see a perfect REST API. And unfortunately, there kind of isn't one. Twilio is doing some awesome stuff, and there's some other ones now that are doing some great things, but especially even 1.5 years ago, there really wasn't one I could just point to and say, it's fully a REST API. And what kind of distinguishes a RESTful API or an API someone calls REST and a real REST API is the use of hypermedia. And we're going to talk a lot more about that. It's not just pretty URLs. And hopefully if that's the one takeaway you guys get from this presentation, it's going to be that. It's not just pretty URLs. It actually involves the use of hypermedia. So this is going to take a little while here on this slide, but I'm just going to go through what REST is. And this is based on the definition from Fielding's paper. And it's just every time I read through it, I learn more stuff. It's just important to go through it. So we're just going to hit it as quickly as we can, and then we'll move on. But REST has basically 6 constraints. You've got the client server, which is a uniform interface separates the clients from the servers. The separation of concerns means that, for example, clients are not concerned with data storage, which remains internal to each server, so that the portability of the client code is improved. Servers are not concerned with the user interface or the user state, so that servers can be simpler and more scalable. Servers and clients may also be replaced and developed independently, as long as the interface between them is not altered. It's also stateless. The client-server communication is further constrained by no client context being stored on the server between requests. Each request from a client contains all the information necessary to service the request, and any session state is held in the client. The server can be stateful. This constraint merely requires that the server-side state be addressable by URL as a resource. This not only makes servers more visible for monitoring, but also makes them more reliable in the face of partial network failures, as well as further enhancing their scalability. Cacheable. As the World Wide Web, clients can cache